अक्षयलिङ्ग शम्भो शिव शम्भो स्वयम्भो
Concrete OEM is a company which produces ready-mix concrete that is batched in centralized batching plants catered through transit mixers and pumping by concrete pumping machines at construction sites. Initially, we have started our commercial operations in Kundratur, which is a western part of Chennai in the year 2017. Later, we have extended our presence in southern part of Chennai at Navalur and northern part of Chennai at Madhavaram with overwhelming support of our customers. We continue to evolve hand in hand with our parent company, Integral Concrete Solutions, having manufacturing plants in Hyderabad and Bangalore, catering to major part of South India. We had concocted and emplaced higher grades of SCC concrete up to M70. We are proud to mention that we have produced a quantum of 50,000 cubic meter of M70 self-compacting concrete successfully.
We at Concrete OEM design, develop and supply mixes as per customer requirements. We have supplied conventional and performance-based mixes from M5 to M80 with different cementitious materials as we are committed to sustainability of environment and reduce the carbon footprints. We are professionals in design and supply of special products like lightweight, porous, temperature controlled and colored concrete. Trust us, we are committed for your satisfaction.
Concrete OEM is a young company. Our current employee average age is 36. And this ready mix requires a lot of stamina and aggressive follow-up. With this young force, we will be able to achieve with a level of greater aggression as well as the passion. Concrete OEM predominantly focus, especially in this year, only for scaling and training our current workforce, not just managers, even at every level of our employee. And this is a very serious commitment. We want to spend close to 10% of our profit only on training. Concrete OEM respects the skills and the expertise. With that mode of operandi, we have taken people, those who got skill, rather than just the knowledge. So that's the only differentiation of concrete OEM. In concrete industry, we would like to design, and even in fact, we have been designing the concrete with the cementitious supplementary materials so that we emit to the level of lesser carbon. So this is how actually we add the value to the environment as well as to the society.
Now we have grown to be a preferred RMC supplier in the realm of RMC industry with a combined capacity of 210 cubic meter per hour. Also, we are in process to venture our presence in Oragadam, which is one of the largest automobile industrial cluster in India.
I'm Shashidhar from Alliance Group, working here as a Senior General Manager. And we are doing a project of 1,300 apartments. We are taking for past 3 years regularly concrete from Concrete OEM. Their service has been very reliable, timely, and the quality of the produce is also good. And their support system post-concreting is also having equally good. We are very happy and we have been associated with them for as long as 3 years since the inception of this project, and we would like to continue so.
Hi, I am Peter. காசகிரானில் ஒர்க் பண்ணிட்டுருக்கேன். 1 இயர்க்கு மேலே ஓஎம்ல காங்கிரீட் வாங்கிட்டு இருக்கோம். நல்லா சூப்பர், பக்கா, நல்ல குவாலிட்டியாக இருக்கும்.
Is Karthik Kumar. On the time concrete schedule has been planned and quickly supplied to. It's very important. We are all happy.
You can trust us.
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 Thank you. Now I would like to call upon Mr. Jagannatha Rao, General Manager Technical Concrete OEM Private Limited, to do the honors of introduction of our speaker.
Good evening, everybody. எல்லாருக்கும் வணக்கம். Nice to see you all. I believe this is a very good weather and it's a good gathering point for all of us. So it's a great opportunity for me to introduce Dr. Manu Santhanam sir to our event with regard to the sustainability and their practices. I would like to have just a small brief about Manu sir. Dr. Manu Santhanam has completed BTech through IIT Madras in July 1994. He did his MS at US May 1996 and PhD he completed in US in August 2001. He has a very vast experience. He started his career as a senior R&D research and development chemist in Sika Corporation USA during 1996 and 1998. Later, he worked as assistant professor for IIT Madras from October 2001 to July 2013. Presently, now he's the current dean of the IIT Madras. He's continuing his dean activities successfully. His professional affiliations, if we see, he is a lifetime member of Indian Concrete Institute, member of ACI, American Concrete Institute, as well as senior member and fellow of RELAM. With regard to awards, what he received Indian Concrete Institute Professor V. Ramakrishna Award of Outstanding Young Researchers in Concrete Technology during 2006. Later, Indian National Academy of Engineering Young Engineer Award 2008. Indian Concrete Institute Fosrock Award for Outstanding Concrete Technologist at 2018. If you see his research highlights, he guided almost 17 PhD students, group of students it is, and 8 MS theses, currently guiding further 8 PhD scholars. He is a principal investigator on research and industry-sponsored project worth 20 crores, which is almost all USD of 4.5 million. He did more than 120 referred journals papers and more than 60 papers in national and international conferences. He has 6 book chapters and 1 co-authored books. It's a great opportunity for us to have such a great personality at this event. We are really honored, so we welcome you onto the dais. All the stage is yours, sir.
Thank you, Mr. Jagannatha Rao, and good evening to all of you. Indeed, a pleasure to come and interact with such an audience, as he rightly said, on a Saturday evening. Many of you have made time to come here. It's indeed pleasurable to see a large audience. Many of you may have also been participants in many webinars over the last 2 years. Now it's become a very common term, right? Webinar, because we've been doing things online for so long. And coming in person together is really a big change and a very welcome change, right? So yeah, I think we have to make the most of today's discussion to try and iron out some issues which lead to poor quality concrete. And in general, poor quality concrete also means concrete that is not sustainable. So in my words, good concrete is sustainable concrete. So I'll just throw some light on aspects within good concrete that is in control of most concrete producers, as well as in control of most contractors and applicators of concrete. So, yeah, of course, my initial talk was supposed to be only on sustainability, and Professor Gettu, my colleague, was supposed to cover the quality issues related to cracking and so on. Unfortunately, because of the weather conditions, he's stuck in Hyderabad. His flight did not make it to Chennai, so he's only coming later tonight. So I'll try my best to cover up for him also, although I cannot be a substitute for Professor Gettu because he's a worldwide expert in as far as high performance concrete and concrete behavior is concerned. But I'll try to do my best to do justice to the topic that has been given to me. So, without further ado, I don't know if you guys can see this part. I think we can just make it a single screen because otherwise half the screen will not be visible. Yeah, that's better, sure. So, wherever you go, everybody says concrete is bad. Okay. Now, today, everybody wants to think about the word sustainability as something that they can achieve. I mean, people have various different impressions of sustainability. Essentially, it means that one needs to utilize resources in a more judicious manner and leave behind something for our future generations, correct? So that's what is the meaning of sustainability. But everybody has various different definitions of sustainability, and because of that, the general impression is that concrete is a bad material when it comes to sustainability. Now, all of you are in the construction business. If I tell you concrete is bad, you'll throw me out of this hall. And if I say concrete is bad, then I'm not doing justice to my career, right? My career is as a concrete technologist, and I breathe concrete basically because that's what I do all the time. Okay. So, concrete is generally touted as bad by people who don't understand how to make it and who are bogged down by the sheer amount of the material that we use. Okay? So generally, they look at this first statistic, right? Nearly 8% of global carbon dioxide emission comes from cement manufacture. Now, there is no doubt that happens. Why does that happen? Because cement is made from limestone, calcium carbonate. When you burn limestone, it will give out carbon dioxide. Same thing when you produce lime, right? When you start burning limestone or calcium carbonate, CO2 gets released. It's only natural that will happen. Then we burn coal to produce the heat to burn the limestone. We burn other fuels to produce the heat to burn the limestone. When you burn the fuel, automatically more CO2 is released because many of these fuels are carbon-based fuels. Coal is basically carbon, right? So when you burn coal, it becomes CO2. So in a cement plant, it is only natural that CO2 will come out. But the problem is a lot of CO2 comes out. For every kilogram of cement that is produced, roughly 1 kilogram equivalent of CO2 comes out. For every kilogram of cement, roughly 1 kilogram of CO2 is coming out. Because of that, and the fact that so much of cement is produced around the world, nearly 4,000 million tons of cement is produced around the world. Of course, which is the largest producer of cement? China, right? In whatever statistic you take, China will be number 1, India will be number 2, except in population where we are going to be overtaking them, unfortunately. It's not something which we should be proud of, but anyway, it's happening. I mean, if you look at industry, a lot of the industry, Chinese are leading in terms of production. Cement is another industry where China alone produces 1,400 million tons of cement. China alone. Okay. Next biggest is India, which is 350 tons of cement, million tons of cement. So only 1/4 of China, but India is still large enough to be second, right? Now, 350 million tons of cement implies 350 million ton equivalent of CO2 going out every year. So that's the main reason. If you take construction as a whole, building and construction industry as a whole, 20% of CO2 emissions are because of this building construction industry. But the question is, can we live without building construction? Obviously no, right? Building construction is important. Infrastructure construction is important. Cement will be used, concrete will be manufactured and used. So we have to learn to live with concrete. Now, while we say that, it is also important for us to look at the truth. If you really look at it, the embodied energy and carbon dioxide in concrete, That means the amount of CO2 emitted and the amount of energy that is required to produce 1 kilogram of concrete is actually lower than what is required for glass or steel. Okay, so concrete is actually, if you take every kilogram of concrete, it's actually a good material as compared to glass or steel. However, because we use so much of it, 25,000 million tons of concrete are used around the world. Second only to water, as I've said on this slide. After water, man uses concrete the most. I mean, that tells you the impact concrete has on our daily activities. And because of this number, the net emission coming out of concrete usage is very high. Okay? And much of the CO2 in concrete is attributable to cement. Okay. Now we are in this room, right? All of these construction elements which are there in this room, the concrete columns, the concrete slabs, the paneling, right? All of this involves processes which are carbon intensive, right? We are evolving carbon dioxide. All of these, to produce this flat panel of wood, it has taken a lot of energy to produce that. So buildings inherently have what is called an embodied energy and CO2. But while the process of the living inside the building is going on, for instance, this hotel has been functional, we are using this hall for this meeting, there's a lot of air conditioning coming, electricity, right? All of this is also producing CO2. Why is it producing CO2? Because electricity comes from power plants where coal is burnt. So that CO2 comes within the kitty of the operational CO2. So two things you should remember with sustainability. One is embodied CO2 or embodied energy. The other is operational CO2 and operational energy. Like when we spend electricity to produce air conditioning, it's operational energy. Okay, so going forward into the future, if we all start taking steps that can reduce operational energy, obviously it will help, right? For instance, instead of using air conditioning for all 8 hours in the night, I can turn it on for 2 hours and put it off, right? That means I have saved 6 hours of operational air conditioning energy. Now, those are the kinds of things that people are being told to practice a lot to make our life more sustainable. However, we also have to realize that whatever energy and CO2 are involved in the materials that we use for the construction process, those are there for life, right? If I have in 1 cubic meter of concrete, if I am evolving 50 tons of CO2, let's say, just for an example, right? When I begin using that concrete, that 50 tons is constant throughout the lifetime because it's embodied, it's in the production of the material. So to make construction sustainable, our goal has to be to reduce the embodied energy, embodied CO2. Those two things we need to take an effort to reduce. So much of sustainability for us as engineers, as concrete technologists, as concrete producers, as construction contractors, is to reduce the amount of embodied CO2 and energy if we really want to make concrete sustainable. Okay? Anyway, having said that, let's move on to look at some solutions as to how we can lower the impact, CO2 impact of concrete. Maybe we can remove this, because otherwise the screen is not fully visible. Okay. Yeah, I think now you can see the whole screen, right? I'll not be a good teacher if I don't let you see my notes, right? So it'll be important for all of you to see the notes so that you remember some points, take home or take away points from the lecture. Otherwise, what I'm speaking may just go off in the air and maybe get into the air conditioning. Anyway, so as I said, we cannot live without making concrete. We have to use concrete. In most geographical location, we cannot reduce the use of concrete. We have to use as much concrete as possible. How do we then lower the embodied CO2 and energy? One approach that most cement manufacturers are taking is to use alternative fuels for cement production. Instead of burning coal, they burn something which is a waste material which does not evolve so much CO2. An alternative fuel. Many cement companies are doing a lot of work, a lot of research to try and understand how this will be possible. Hydrogen as a fuel. You might have heard that there's a lot of research work going around the world talking about the use of hydrogen as a clean fuel. And that is something that people are also exploring as far as cement production is concerned. But as far as us civil engineers are concerned, we can adopt strategies to reduce cement consumption in concrete. Now you must be wondering, common knowledge is that when you use more cement, you produce better concrete. Why is this guy telling you to use less cement? The idea is, as I said earlier, most of the CO2 impact of concrete is because of cement. So if you use less cement, you use or you produce less CO2, you have less embodied energy. But how do you make do with less cement? Can you produce good concrete with less cement? Yes, by the use of supplementary cementing materials. And what are these? Fly ash, slag, calcined clay, many other materials are available, which I'll talk about briefly later. Right? Chemical admixtures like superplasticizers can also help you cut down the amount of cement that you use in concrete. How do you do that? I'll give you an example later. The other thing is to use performance specifications instead of prescriptive. Now, many of you may be doing projects where the job site will have specifications saying, this is an M25 concrete, but you have to use 400 kilogram cement here. I mean, why do we care how much cement is there? We want the performance of M25, right? Why should I worry about if I have 320 cement or 400 cement? If my job is to give you M25 concrete, I produce M25 concrete. So that is performance specification. I don't worry about the extent of cement that I put into the system. I worry more about the performance. I need to guarantee the performance. Now you go to the electrical shop and buy a light bulb. Do you ask the person what is the wattage? Okay, wattage maybe you'll ask because you need to have your room lit properly. But do you ask the person, okay, what is the density of the tungsten filament that is used here? No. Do you worry about what filament is even used? No. How do you buy that bulb? The person puts into the socket, turns the switch on. If it works, you buy it. That's it. That is performance. In concrete, we can achieve this level of understanding and buy concrete based on performance. And that's how we'll be able to cut down this cement content. The other thing is to adopt approaches to maximize aggregate content in concrete. Again, this goes against the common man's perception. Common man thinks more cement in concrete, the better. But a concrete technologist would tell you, more cement in concrete, more are the problems. More aggregate in concrete is better for the concrete. Why? Because aggregate is inert. It maintains its shape. It maintains its size. It does not react with anything that comes in, mostly. There are some aggregates which have a problem, but most of the aggregates that we are used to, at least the ones in Chennai, aggregates need to be maximized to improve your concrete properties. So please revisit your mixed designs. See how well you have put in your aggregates. Are you maximizing aggregate content in concrete? And today there are approaches, simple approaches based on good gradation that you can do to maximize aggregate content in concrete. Okay, so those are the 4 major ways to reduce cement consumption. I'll talk briefly about at least 2 of them. The other thing is to use alternative cements. Instead of OPC, which we are commonly using, we can start thinking about using alternative cements. For instance, special cements that are carbon neutral. Okay. As we go on more and more, I don't know how many of you are aware of the carbon tax. Okay, many industries that are having processes that evolve a lot of CO2 will have to start paying carbon tax. if you've heard about this company called Holcim, it's a largest cement manufacturer in the world. They had a very successful business in India where they had taken over ACC and Ambuja, right? But today they sold it off and packed up their cement business in India. Why did they do that? Not because it was not profitable, they had a very good profit in India, but because their overall carbon tax or carbon emission calculation around the world was exceeding so much that the amount of money they had to pay for the CO2 emitted was simply not enough for them to make a profit with. So they quit their cement businesses in India, as in many other countries like Indonesia also, and they have mostly concentrated themselves in Europe. So CO2 tax will become a major thing in the future. Okay, we are not thinking about it, but all of it will hit us one way or the other. You all know that our Honorable Prime Minister has set a target of net zero by 2070. It's actually a very big proclamation. We have only 48 years to 2070. Net zero means we ultimately don't emit any additional CO2 into the atmosphere. That's not easy. That's going to take a lot of sacrifice and a lot of understanding of the system. We need to deepen our understanding of the system. Right, so alternative cements, I'll give you one or two examples later, but that's not the main feature of today's presentation. Recycled concrete and industrial waste for aggregate is an absolute must. We are going on using natural materials, natural resources. We cut down mountains and make rock out of it, stone out of it to use in concrete. How long will this go on? Earlier itself, we took a lot of sand from riverbeds and used in concrete and totally altered the course of rivers and plundered our mother nature, right? Today we are cutting down mountains, making aggregate, making sand and using it in concrete. Of course, we need material for concrete, but much of that is also available from the concrete that we demolish. So much concrete is demolished. So much concrete is wasted on job sites. A lot of concrete is wasted, right? Everything does not get used. A lot of concrete gets wasted. Can we at least retrieve the aggregate from the wasted concrete and reuse it? All of this is absolutely important to make the whole process sustainable. There is also techniques of using CO2 to cure concrete. Okay, again, that will be a topic of a different lecture, so I'll not go there today. Repurposing concrete elements when possible. What do you mean by repurposing? Now, you might have seen that the government has put up, the municipal corporation has put up these big dividers on the roads. Large concrete blocks they put up, right? Of course, first question is, why do you need such a large divider for the road? Why so much concrete? Okay. But then still, since they have put it up, at the end of life or when they want to change that road a little bit, what do you do with these blocks? Do you take and dump them somewhere? Better not to, right? Can we use them elsewhere? Similarly, in structures, like in temples, we've been doing that for ages, right? Old temples, these massive walls made with stone masonry. What people have been doing is, if some section gets damaged, they take the entire stone block, keep it aside, repair the damage, and use the stone block again. That is what we need to learn from our ancestors and forefathers. We need to start thinking about designing for repurposing. If there are students in this audience, think of that as a possible way that you want to spend your career. Repurposing concrete elements as far as possible. Don't always build with new material. Repurpose, reuse what is already available. Plain concrete does not degrade with time. Plain concrete is like a rock. It will last for a very, very long time. Only when you have reinforcement in concrete, degradation starts within, depends on how good your concrete is. Your steel starts corroding, so degradation happens. If there is no steel in concrete, your structures will last for many, many, many years, maybe even 1,000 years, right? Many of you must have asked this question, no? The structures from old times, they've lasted 1,000 years, but today you can't build a structure that is free of damage for 10 years. Why is this damage coming? Because there is steel in concrete. And we can't live without steel. Because reinforced concrete is the way that we do our engineering. We can't design structures without reinforcement. But then, that's the answer, right? The old structures, they had no steel. So the material lasted for thousands of years. plain concrete is pretty much similar. There are evidences of Roman concrete from 2000 years ago surviving seawater environment and still maintaining its strength and durability. It's possible. Without steel, concrete will survive for very, very long time. But we should learn how to repurpose, reuse those elements of concrete without really, even recycling of the concrete, breaking it down into aggregate size involves a lot of energy, right? If you can, without recycling, use the entire concrete block, why not do that? Why do you want to break it up again? Unless it's damaged already, in which case you have to break it up. But if it's not damaged, why don't you use it again? So repurposing, please start thinking in that direction if there are students here. So just to give you some idea about supplementary materials, many of us are used to fly ash because it's available in India plenty, because India produces more than 60% of its power from coal-fired plants. And because of that, there's a lot of fly ash available. Much of this, of course, the good quality fly ash gets taken away by cement manufacturers. The ready-mix suppliers typically get the second grade. We need to ensure that that is of a quality that is good enough, right? We need to go out of the way to ensure that the specifications are met by the fly ash that is collected. Nevertheless, fly ash is available in large quantities for collection. A lot more fly ash is available in the thermal plants in ponds, but that's not of good quality. You really need to work hard to make that into good quality. Okay? So, while fly ash is there, among the other alternatives, the one material that is available aplenty is clay. So if you take clay and burn it, you can activate it and make it reactive. Fly ash, on the other hand, you just collect it and put it in concrete. It acts with the lime generated during cement hydration. Clay needs to be burnt. So in that way, it's not as sustainable to use clay as it is to use fly ash. However, what we have shown through research is that you don't have to get pure clay for this purpose. All the overburdened clay that is already dumped in mines, if you go to Gujarat and Rajasthan, there are tons and tons of these kaolinite mines where they are getting the semiconductor grade kaolin, where they use kaolin for semiconductor, paints, ceramics, paper. All those industries use pure kaolinite, white China clay we call it, no? In such mines, there's a lot of impure clay also that is dumped. I mean, it's totally wasted. But that has very good qualities as cementitious material. So you take that clay and burn it partially, you can use it as a cement. So what we have to look at as far as materials for substitution of cement is concerned is that we need to be able to understand how much are they available around the world. Again, my appeal to students and faculty who are here from colleges is to start looking at availability as an important criterion before you decide to use that in concrete. Because concrete, staggering numbers, 25,000 million tons are going to be used. And if we have only like few kilograms of the waste available, it is not a viable solution for concrete industry. We need to look at masses. We need to look at large volumes. And that's where calcine clays really give a good thing. The question we need to ask is how much cement we need in concrete. Now, you take a very old structure, which is 50, 60 years old. You take a piece of concrete from inside. If you do microstructural analysis, if you look under the microscope, you'll see that a lot of the cement is not reacted. Okay? Theoretically, it needs each gram of cement, if it has to react, it needs at least 0.42 grams of water. And that's in an ideal world. That means each cement grain is able to get surrounded by water of that much quantity, then only it will fully react. Okay? If you take chunks of concrete from 50, 60-year-old buildings, you'll see that a lot of the cement is not reacted at all. Is that good or bad? Is that good or bad? Sorry? Yeah, it's a wastage because so much of cement is not reacting. Much of it is just sitting there as a filler. It is not bad for the concrete because it's still occupying volume and giving strength as a filler. But why do we need to put cement as a filler? Why don't we use other materials? For instance, the supplementary materials. This could be a very convincing argument for us to understand that yes, we don't need so much cement. But at the same time, you need to have an understanding of the chemistry as to what kind of blends or mixtures of cement with the supplementary materials will produce the right level of performance in concrete. Now, many of you may have, many times the concrete that is produced with blended cements is of a superior quality in the long term, as a result of which it is more durable, less crack prone, and because of that you may have much longer life, and that is having a social impact. And then of course economically there are benefits, because for the same level of performance your concrete cost will be now lower when you reduce the cement and use supplementary materials. Okay? Now, of course, getting a little bit into the chemistry, supplementary materials could be of the types which have some calcium in it. For instance, slag that you get from from iron and steel manufacture that has sufficient quantity of lime, calcium oxide. So that's called latent hydraulic material. Whereas fly ash, which we get from thermal power plants, does not have enough calcium. It is deficient in calcium. It needs the lime that is generated from cement hydration to do the reaction. That's called a pozzolanic material. Okay? So many of you may have heard these terms, understood them during your college days, but may have forgotten. Slag is latent hydraulic, which is why when we use slag in concrete, we permit even up to 70% replacement of cement by slag. If you buy a Portland slag cement, PSC, it is likely to have at least 50% of replacement of cement by slag, at least 50%. And today they are trying to push it up to 70%. 70 is allowed anyway by standards. When you go for Portland pozzolan cement, PPC, the amount of fly ash is restricted to 35%. Why is it? Because fly ash cannot react on its own. It needs the lime to react. Slag, it has sufficient lime, but reaction needs a little bit of activation. It can react on its own. That's why so much of slag is allowed and less of fly ash is allowed. Okay? Nevertheless, both of those materials, slag and fly ash, are very useful to produce good quality concrete. Now, just going back to the previous one. So, what you need to look at whenever you use special cements or blended cements, when cement is replaced by blending materials, is that the period of curing may have to be suitably altered. Why? Because when you replace cement by another material, the hydration process slows down. Why does it slow down? Because all of these other materials take some time to generate their reactions. As a result, if you are curing ordinary Portland cement concrete, OPC concrete, for 7 days, slag concrete you may have to go up to about 10 days. Fly ash concrete you may have to go up to about 14 days. Okay? Why? Because if you don't cure well, you are not giving a chance for these materials to give their full potential contribution. Right? Just like cooking, right? Just like cooking. When you put rice in the pressure cooker, you can let it go for 2 whistles, or you can let it go for 6 or 7 whistles. With 2 whistles, you get rice that makes good biryani. With 6 whistles, you can get rice that makes good thai sadam. Depends on what you want, right? You have to make sure that you pay attention to the curing process to get the best potential out of fly ash concrete. If you cure fly ash concrete for only 3 days or 7 days, there's no point. You are not utilizing the best out of the material. So as users, you need to pay attention to that fact. If you think that you are actually going to be wasting your time and productivity by doing extended curing, it's a very bad notion to have, because you put in that extra bit of care in the beginning, your concrete is going to last for 10 more years. Okay? Please pay attention to that, because all of these special concretes, wherever cement is replaced, your long-term performance is automatically going to be better only when you take care of the concrete in the beginning. You have to ensure that the concrete has been nurtured and developed well for a good long-term performance. Anything that you nurture well will perform well in the long term, as in concrete, as in life, right? Anything that you nurture well in the beginning will perform well in the long term. But many of us on construction sites don't have any time for concrete, right? Most of you know, designers don't even think about concrete. They say 40, next day somebody comes with M40. But do structural designers understand what are the characteristics that are required out of concrete? They don't. It's up to the concrete technologists to ensure that they bring out the best quality concrete. Mixed design is not something that can be done in one day. Okay, even you need at least 28-day results, no, to certify a mixed design. But many sites that I've been involved with, I see that they are ready to pour the concrete next day. Today they come for requirement of mixed design. That is the kind of treatment that concrete gets. And that's really unfortunate. We need to start giving respect to the material. We need to start understanding that when we start putting other things in the material, in the concrete, we have to be able to predict the properties well and get an assessment truly of how concrete is going to behave in the long term. Okay? Anyway, I'll come back to that maybe when we have our discussion. This is an alternative material called alkali activated cement. Many of you may have heard of this, like for instance, alkali activated slag. People are saying this is a green material because no cement is used, no OPC is used. You just use slag, you mix alkaline activators, and the material basically hardens through a alkali activation process. It's a little bit different than cement hydration, but yes, it can happen. However, again, the question is quantities. Do we have enough of the activator materials available? Not enough to replace conventional concrete. Again, other special cements that are slowly coming in, but then again are restricted by the amount of material that you can produce, are calcium sulfoaluminate belite cement, magnesia cement, and wollastonite cement. So I'll not spend time on this. If necessary, some of you can ask me later about this. The question is there a future without regular cement? It's very interesting to note that if you look at the distribution of the elemental composition of the Earth's crust, whatever is available on the top surface of the Earth, only that can be easily mined, right? If you look at that, most of the elements that we have are silica, alumina, iron, and calcium. Already cement is a very good mixture of all these four elements, of oxides of these four elements, right? So you cannot really have any other material that can look to replace cement in very large quantities. Okay, so technically there is no real future. But then how do we make concrete sustainable? We've just told you that cement is going to be responsible for so much CO2 emission. Use less cement. Use less cement by making appropriate use of supplementary cementing materials. In my personal opinion, today, with the extent of knowledge we have on concrete, it is a criminal waste to make concrete with plain OPC. I can tell you that much from my side. It's a criminal waste if we are making concrete with OPC today. If we are not making it with OPC with fly ash or OPC with slag or directly the blended cement PPC and PSC, we are really doing a big disservice to the construction industry. As concrete producers, as contractors, we have to take that bold step and say that no more OPC. I'm going to make do with alternative cements and make sure that my processes are proper. That's my personal opinion. I hope that many of you will also believe the same way. Now, chemical admixtures. Very often I've seen people making M20 concrete with 400 kilograms of cement. Again, already using OPC is a criminal waste in my opinion. If you're going to put 400 kilograms of cement in an M20 concrete, I'm sorry to say this, but you ought to be in jail. Why? Because why do you need 400 kilograms cement to produce M20 concrete? Okay. Super plasticizers are available. They reduce the water demand. Now, typically what we do, when we add a super plasticizer concrete, we make it flowable. Or we keep the workability constant, we add super plasticizer and reduce the water. That way we increase the strength and durability. But what if you do it this way? You don't change your workability and strength. You just reduce the water, and by an equivalent amount, you also reduce the cement. To give you an example, you hear concrete 1, you have 400 kilograms of cement, 200 kilograms of water, it produces a slump of, let's say, 150 millimeters. Second concrete, you have reduced cement by 50 to make it 350. So same water to cement ratio, 0.5. Now your water content is 175. You have done that by use of 0.5% of super plasticizer by weight of cement. That means about 1.75 kg of super plasticizer. And that gives you a slump of 150 mm also. So in effect, what you have done, you've reduced 50 kilogram of cement. You've reduced 25 kilogram of water. Many of us don't understand this. Tomorrow, apart from your carbon footprint, you are also going to be questioned on your water footprint. More water you use, the less sustainable you are, okay? You have to start thinking about ways you can cut down water because we don't have good quality water available anymore for construction. You have to start looking at this aspect seriously. How do we cut down the water content? And one way is by using chemical admixtures like super plasticizers. Today, you have to use chemical admixtures. You have to use super plasticizers. Not because I worked for a construction chemical company earlier. It's not because of that. I sincerely believe that you have to use super plasticizers to get the performance you want. Many of you may have this thought that I'm putting additional material in my concrete, may spoil the performance in the long term. Don't worry about that. Super plasticizers are only intended to act in the first few hours to help you produce concrete of a given workability and retain that workability. That's it. They don't do anything in the long term because they are there in very small quantities. In 2,400 kilograms, you have only 1.75 kilograms of the super plasticizers, so nothing, okay? Super plasticizers are absolutely essential today for any grade of concrete, even if it is M10. Please make it with super plasticizer because that will ensure that you cut down the quantity of cement required to produce the same grade of concrete, okay? Remember this. If nothing else from this lecture, this is one thing you should take back home, definitely. Now, of course, as I said, aggregate is something that we are using. There are sources of alternative aggregates also. Many of you in the colleges may be already working with some of these alternative sources. One is, of course, granulated iron slag or air-cooled iron slag, steel slag, copper slag aggregate. These are all alternative sources which are already allowed in some way or the other by our IS specifications. IS 383 is the aggregate specification. And there already, many of these are already listed, including recycled concrete. Okay, today IS allows you the use of recycled concrete. So at least for the amount that they allow, please start using recycled concrete as an aggregate. Now, the problem with recycled concrete is you are not mandated to use it. Okay, you are allowed, you're given a choice to use it. Tomorrow, if there's a government regulation that every concrete should have at least 20% of natural material replaced by recycled, then you'll definitely start using it. And again, it's a question of policy. If you can have policies initiated to get this compulsorily made, definitely it'll happen. But please start looking at the use of recycled concrete as a part of your aggregate. It's definitely important. You have to get there. Now, again, because we need so much quantity, when you use alternative aggregate also, make sure that you pay attention to the fact that is enough material available. Okay? You have to do a proper assessment of the quantity of material that is available. You can't just start using something. I've seen work done at colleges where they're using printed circuit boards from computers which have been thrown away. They are cutting this into aggregate size and using it. Okay, it may be an interesting student project, but please remember, this has no practical implication to the industry. Nobody is going to allow you to put that. First of all, because it's got toxins in it. Unless you detoxify these boards, you're not going to be able to utilize them. Secondly, the characteristics that you get from plastics are very different from what you get from stone or from even recycled concrete. So make sure that you understand those implications before we start putting in, okay? Many of projects in colleges these days, they want to replace one by other. That's not the way it works. Understand how this material will be useful first, and then think about replacement. So materials are only part of the story as far as sustainability is concerned. The process is also important, how you do the entire process. As I said, much of today's emphasis is to lower the operational CO2 and energy. For instance, reducing or making air conditioners more efficient and so on. That reduces the operational CO2 and energy, but a lot of the emphasis needs to be on embodied CO2 and energy during construction. Policy, as I said, is very important. And of course, it needs a concerted effort across different industries. It's not just a question of civil engineering industry, right? The architects also have to be in line with these requirements and ensure that they understand these processes quite well also. Right, so I'll now shift over to a slightly different domain, but before I do that, maybe it'll be good to take some questions now, rather than just me talking. I can hear some of you also talking.
Any questions, please?
Yeah.
Good evening, sir.
Good evening.
You mentioned about demolished concrete being used for recovering aggregates.
Yeah.
Is there any processes where we can use the demolished concrete for supplementary materials in the mix design and probably sustainability?
Okay. So what crushed demolished concrete, right? You can produce coarse size aggregate, fine size aggregate, but very often what happens is the cementitious part that is there in the concrete gets crushed to very fine sizes, less than 125 microns. So technically, that 125 microns of the cement powder or paste powder that is available has a potential to be utilized as supplementary material also. There are worldwide efforts to see how best this can be utilized with least energy input. Okay? So yes, there are ways to do it.
Thank you, sir.
No other questions? Either I was very clear or not clear at all.
I have a question here.
Sir, good evening, sir.
Yeah.
So when we do the pile foundation, the concrete is done by trimming method. There they specifically say you have to use 400 kg of cement to get a slum of 150 to 180. So is there any chances to reduce cement content over there in underwater concreting by trimming method?
Sir, again, your concrete characteristics are defined in terms of the workability that you want and the strength that you need to make it, right? So certainly you can design your concrete with lesser cement also. Of course, with concreting, you are looking almost like a flowable concrete. When you make flowable concrete, generally cementitious content needs to be high. Cement content does not need to be high. Okay? So that 400 could easily be 300 of cement and 100 of fly ash, something like that. It's possible. So you have to design the concrete to achieve the quality, not necessarily worry about how much cement you have.
So then it basically should come from the specifications, sir, where it has been prepared by the structural people or architects.
Exactly.
Or from the state government departments, sir.
Very good, very good point, sir. I'm always hoping that wherever I talk these things, specifiers are also in the audience because they are the ones ultimately that make that difference.
Yes, sir. Yes, sir.
Exactly. I totally agree. There are designers and structural engineers who are in the audience. Please start looking at, I mean, if you think that fly ash is a new material, I have to tell you that there is at least 70 years of solid research data available on fly ash. There is more than that available for slag. 1960s onwards, people have been using these materials left and right. There is no question of not having this data now. Indian data, if you want, again, we have sufficient amount of data. Wherever it's needed, please stop using OPC and start using blended cementitious materials.
So one more
Even
question,
we have also written letters to all major infrastructure projects. CMRL, for instance, we actually convinced them. We had to have dialogue with them and convince them that yes, they can start looking at slag cement, and they have very positively responded to us also. I'm hoping that this will pervade to other applications also. Yes.
One more thing, sir. Normally, most of the designs come to IIT for approvals in the initial stage itself, like CMRL or even the state PWD governments or any private also, sir, actually. There itself, I think so, since you are in IIT, you can cut short the cement usage, sir, quantities, where specifically they insist for 400 kg when we do piling, sir, actually. And they ask us to do OPC. Suppose we go for PPC, then what happens, the curing strength, the 7-day strength and 28 tons we don't achieve in PPC and all, sir, actually. Okay. So that time we face that problem, actually. They say your concrete is failed.
Yeah.
And whereas when you do a 35th day, you get the strength actually.
Right.
They don't have the patience for the curing
Exactly.
times are actually.
Exactly. Yeah, I think you have described the larger problem in the industry. I totally understand. In fact, there are projects where I'm saying that don't even worry about 28 days strength, go for 56 days strength. Go for 50, especially when you're doing mass concreting, right? Where you need low heat of hydration, you have to cut down cement and use fly ash as much as possible. Right? When you start doing that, your strength gain rate is going to be slower. So you need to be able to allow for the higher age of strength gain. Because who loads their structures for full compressive strength? In fact, we never load it, at least not in the 28 days or 56 days or the first few days of construction. Not going to happen. So again, yeah, sir, but it's easy for me to say this. It's a big challenge to convince people, right? It's a big challenge to convince people. But yes, slowly by dialogue, by understanding this better, I think we have to do it. You're right. Yeah, unfortunately, the designs that do come for approval, they are mainly coming in for design checks, structural design checks, third-party certification. People don't seek opinion on concrete as much because, again, as I told you earlier, concrete is taken for granted. People say, okay, today I want M40, tomorrow somebody will come and deliver M40. So, yeah, but yes, more effort is needed to really convince people. Yes, I agree, sir. Thank you. Yeah.
In case of precast concrete,
Yeah.
it is advisable to go with blended cement concrete like.
See, again, I think you are speaking from the point of view of productivity of precast concrete.
Yeah.
Yeah. So yes, there is significant data which shows that blended cements respond very well to heat curing if you're doing heat curing based productivity enhancement. Heat curing works excellently for slag and quite well for fly ash to reduce the time period it requires to gain strength. Much of the fears of people with precast were related to the fact that strength gain will be slowed down.
Yeah, earlier strength is expected wherever we go with precast cement.
Exactly, exactly. It's a question of designing your concrete appropriately. You can do it. Definitely you can do it. We have done a lot of work with early age strength, with concrete, with fly ash and slag also. It's possible. Yes.
Whereas one of our project, 80% of the concrete, we are going with OPC.
Yeah.
Without blending. That's why.
Yeah. Again, if there's a policy tomorrow that comes out that you can't use OPC, definitely you'll not be able to use. Then you have to find a way to use blended cement.
Already we
and
have
it's possible. It's possible already.
Already cement industry is, in that case, like they are, most of the places they are restricting OPC.
Correct. Because there's a lack of confidence in the fact that other materials can achieve it. What we are thinking is, okay, if we use 400 kilogram OPC to produce a certain characteristic in one concrete, if you are saying that you want to use PPC, they want the same performance at 400 kilogram PPC. Maybe that's where the mistake happens. What you need to do is redesign the concrete. Redesign the concrete. Maybe you may need about 410, 420 with a slightly 0.02 lower water cement ratio to get the same performance. But you need to redesign the concrete, right? So that's what you need to look at. But in the process, you are actually saving a lot of cement. And that's, again, one strategy that has to drive your choices for material selection.
That specifically comes to precious concrete member. They are specific about that.
Yeah, exactly. That's because of this fear that productivity will be affected. But no, that's not correct. We can design concrete to have high productivity with slag and fly ash also. And many of the problems that come in the long term because of heat curing for OPC do not happen when we do replacement. Many of the problems, which people don't realize because all they want is early strength, they get it and then they forget. But in the long term, the durability depends a lot on the, again, I come back to cooking always. You cook something very fast, you get the result quickly, but it may not taste very good. Slow, nurtured cooking gives you much better taste. And that's exactly the case with heat curing. Heat curing gets you early strength, but long-term durability is actually compromised for steam-cured concrete. Whereas with blended cement-based heat curing, you will get concrete which is in the long-term also quite durable. Yeah. Again, there is a lot of data on this. People only have to ensure that they pay attention to the data.
So one more question, sir.
Yeah.
Sir, in blended cement like PPC, the maximum fly ash percentage is capped to 35%, sir.
Yeah.
So some of the even cement manufacturers also, so they are blending more cement, more fly ash on that, like 40 to 45% also yielding good results. So your opinion on that, sir?
So see again, fly ash in PPC is restricted to 35.
Yeah.
Yeah.
Yes, sir.
So technically, in the cement you should not have more than 35. If they are putting 40 or 42, they are not really truthful in their approach. However, as a concrete producer,
Yeah.
if you are able to use that cement and still get the strength and other properties associated, that's a positive for you. That's what I can think. Yeah. Because if they are able to produce their PPC to produce the same concrete at a higher fly ash replacement level, they are actually doing a big favor to you. Although they are making more money because they are selling cement with lesser clinker and more fly ash. But as a concrete user, if you are getting the same performance, in my opinion, there is nothing wrong. In fact, what happens is because of this PPC limit of 35%, many people think that 35% is also the limit of fly ash to be used in concrete. So if I take fly ash in RMC and use it, many specs say that you can't go more than 35%, but that's not true actually. Okay, concrete you can actually go for higher blending also. Again, concrete is something that gives the opportunity to experiment, but we need to be confident. So for that we need to produce our own data, right? But yes, if they're selling it like that, it's not truthful on their part. But from the concrete user's perspective, if you're getting your performance, you need to be happier that yes, there is more fly ash in your concrete.
Thank you.
Any cement manufacturers here? Huh? There are cement manufacturers also.
All RMC plants they are doing.
Sir, maybe I think cement manufacturers have to answer that question.
Sir, good evening.
Yeah.
Here, I am representing Chettinad Cement.
Sir.
I'm Suresh here.
Yeah, hi.
I don't want to answer his question because it is purely commercial. I have a different question.
Sure.
The trend today is like the admixture compatibility is becoming a bigger challenge.
Yes.
Whether people should change cement for not being compatible with admixture, or they should change admixture for not being compatible with cement.
Very good question. So, in my experience,
we are also facing the challenge.
Yeah.
You know that both need not be compatible all the times, all the products, all the brands.
Yeah.
But people are not able to understand that. It is something, like before
Correct.
doctor writes a prescription, he asks, you have any allergies? To check the compatibility.
Correct.
So how do you look into it, sir?
Yeah. So that's a good question because as I said, super plasticizer are essential for all the concrete. But at the same time, before you use a super plasticizer, you need to check whether the combination of the super plasticizer and cement that you're going to be using in this project, is that working well together or not? Now, it will take you only about 2 hours of additional testing to establish that. There are ways and means to do that. Just 2 hours of additional testing. You don't even need sophisticated equipment. You need a simple cone and a funnel to establish this compatibility. So testing can be done to establish the compatibility. The problem is, what if it's not compatible? What do you do? The question has been raised, do you change the admixture to make it compatible with the cement, or do you change the cement to make it compatible with the admixture? Now, this is only my personal observation. In most sites, what I see that the admixture is changed. The admixture manufacturers keep changing their formulations until they get the approach right. In one such project, which I came to know of, this was being done and the admixture manufacturer had to make some 5 to 6 changes in their formulation, but nothing was working. Cement manufacturer then studied their cement a little bit more and found that the problem was with the issue of the aluminate and sulfate in their cement. They went and changed it and it was perfectly working with all the admixture formulations. So the problem could be from either side. And it only takes an open mind to actually accept it and do the thing. So I was very happy that the cement manufacturers actually paid cognizance to the fact that there is possibility that cement could be at a problem. But generally what happens is, on a site, if you ask the contractor, they'll blame it on the admixture. Because admixture is an additional component. It's an extra masala that you put into your concrete. That problem must have come because of that. In some instances, yes, it does come, but that's because of improper use of the material rather than material itself. But yes, so I think a more suitable dialogue is necessary between the cement and admixture manufacturers instead of the finger pointing that typically goes on whenever non-conformance reports are generated. So I think we all need to accept that yes, problems can happen because we are using so many different materials nowadays, but yes, we need to be able to accept it and move along.
Thank you, sir. Thank you.
Hi, sir. My name is Ranjit. Good evening.
Good evening.
While I am studying in college time, one of my friends, they are using that rice husk and coconut, these things for the environmental purposes.
Yes.
So still it's not coming to the market.
Yes.
So what is the main criteria to introduce those things in the concrete, like some of the industries?
Yeah, good question. So a lot of agricultural products are suitable to use in cementitious materials. Rice husk, for instance, when you burn it, it produces ash. Now, many agricultural plants, basically, they take the silica from the soil while they grow, right? So when the nutrients are exhausted, like sugarcane also. Sugarcane, when you crush the sugarcane and extract the juice out, you only have the bagasse. We call it bagasse, right? The fibers, carbon fibers. But there's a lot of silica in it also. So when you burn this bagasse, because rice husk and bagasse are very useful for burning, because they produce very good temperatures for sugar mill operations and so on, and also to produce electricity. All sugar.
Sir, one more thing. In these days, I want to register one thing. We are using M40 grade concrete for a raft foundation.
Yeah.
So in the design mix, we are using 60% of GGBS and 40% of cement. So that I want to research these days.
That's excellent.
For alternate materials.
That's very good. That's very good. Next time you do this, out of the 60% slag that you use, replace 20% of that. But in my opinion, they should not be rejecting it.
Okay, thank you.
Sir, good evening, sir.
Yeah. Oh, yeah. Hi.
சிமெண்ட் பற்றி எல்லாம் பேசுகிறாங்க எனக்கு கேட்குதுங்களா இப்போ?
Sorry?
ஐயா, இப்போ என்னன்னா சிமெண்ட் பற்றி எல்லாம் பேசுகிறாங்க, எனக்கு வாட்டர் பற்றி ஒரு சின்ன டவுட் இருக்கு. இப்போ நம்மளுக்கு அவைலபிள் பார்த்தீங்கன்னா நாட் சூட்டபிள் ஃபார் கன்ஸ்ட்ரக்ஷன் பர்பஸ் அப்படின்னு சொல்லிடுறாங்க.
சரி.
ஸோ அந்த வாட்டர் வச்சே நம்ம டிசைன் பண்ணி அச்சீவ் பண்ணுற மாதிரி பண்ண முடியுங்களா? குவாலிட்டி ஆஃப் வாட்டர் அதே இருக்குது, நாட் சூட்டபிள் ஃபார் கன்ஸ்ட்ரக்ஷன் பர்பஸ்ன்னு சொல்லிடுறாங்க, ரெயின்ஃபோர்ஸ்மெண்ட் இது. அதே யூஸ் பண்ணிவிட்டு நம்ம ஏதாவது டிசைன் மாற்றி பண்ண முடியுமா அப்படின்னு ஒரு சின்ன கொஸ்டின். ஏன்னா இருக்கிற நல்ல சோர்ஸ் வாட்டர்லாம் நம்ம யூஸ் பண்ணிட்டு இருக்கோம். இதை விட்டு ஏன்னா இது ட்ரீட்மெண்ட் பண்ணுறது காஸ்ட் வந்து சேமாக வராது, நம்ம காசு ப்ராஃபிட்டாக வராதுன்றதுனால தே ஆர் கோயிங் டு திஸ் மெத்தட். ஓகேங்களா? ஸோ இதுக்கு ஏதாவது ஆல்டர்னேட் இருக்குங்களா?
கரெக்ட். ரொம்ப இம்பார்ட்டன்ட் கொஸ்டின். ஏன்னா போக போக இன்னும் குவான்டிட்டி ஆஃப் வாட்டர் இன்னும் கம்மியாகிட்டே இருக்கும். குட் குவாலிட்டி வாட்டர் வில் கீப் ரெடியூசிங் இல்லையா? ஸோ அதுக்கு வந்து மெயின் திங் தட் யூ நீட் டு லுக் அட் இன் வாட்டர் is the chloride, sulfate, alkalis. இந்த மூணு ஐட்டம் வந்து ரொம்ப கேர்ஃபுல்லாக நீங்கள் பார்த்துக்கணும். இதை தவிர்த்து ஆர்கானிக் மேட்டர் இருக்கும். That will be also there. Organic matter, dissolved solids may be there, hard may be there, right? So those are not as critical as chloride, sulfate and alkali. So அந்த மூணு நீங்கள் கரெக்டாக சப்ரெஸ் பண்ணி பாக்கி ஜாஸ்தி இருந்தாலும் என்னோட ஒப்பீனியனில் அந்த வாட்டர் யூஸ் பண்ணலாம் கண்டிப்பாக. ஆக்சுவலாக வந்து ட்ரீட்டட் வாட்டர் நம்ம பாத்ரூம்லேருந்து வாஷ் வாட்டர்லாம் இருக்குல்ல, அது ட்ரீட் ஆகி வருது இல்லையா, அது கூட கான்க்ரீட்டில் யூஸ் பண்ணால் சேம் குவாலிட்டி கான்க்ரீட் ப்ரொடியூஸ் பண்ண முடியும்னு எங்களுக்கு ரீசர்ச் டேட்டா இருக்குது. ஆனால் அந்த அளவுக்கு மக்கள் அதை ஐ மீன் ஒத்துப்பாங்களா இல்லைன்னு தெரில. பட் யூ கேன் டூ இட் அண்ட் டுமாரோ யூ வில் ஹாவ் டு டூ இட். டுமாரோ you will have to do it because there will not be enough water available, because we have to drink water, no? We have to drink water. For drinking itself, it's getting less. So obviously for making concrete, we have to start using treated water. And it's possible to use treated water to make concrete with it. But you need to keep chloride, sulfate, alkalis to the lowest level possible. In fact, இப்போ புது IS 456 இப்போ வர போகிறது, அதில் கொஞ்சம் ரிலாக்ஸேஷன் இருக்குது வாட்டரில். You can start using alternative water. ரெண்டாவது வந்து, if you look at the code carefully, it says that the engineer on site has the power to approve alternative materials if they are confident about the result. Code doesn't say that water, cement, everything has to be in the same way as it is put in the code. It also tells you that the engineer can make that decision. So as an engineer, if you're making concrete, and if you're reasonably sure, if you have done enough work, data, நம்மள்ட்ட டேட்டா நிறைய இருக்கணும், அவ்வளோதான். That's the main thing. அந்த டேட்டா வச்சு நம்ம ப்ரூவ் பண்ண முடியும்னா that will be great. அப்போ கண்டிப்பாக நம்ம யூஸ் பண்ணலாம், யாரும் நிறுத்தத்துக்கு வாய்ப்பே இல்லை. One thing please realize that when we are going for that high quality water that we want to use in concrete, it is from the perspective of reducing the potential for long term damage to concrete like corrosion and all that. As long as you've understood that this water you're using is not going to cause that, you can go ahead with using it. Okay? Yeah. Only thing, sometimes some salts may result in efflorescence. Patches எல்லாம் ஃபார்ம் ஆகலாம் கான்க்ரீட்டில், அது கொஞ்சம் பார்த்துக்கணும் நீங்கள், அந்த மாதிரி பொட்டென்ஷியல் இருக்கா இல்லையான்னு. ஸோ ப்ராப்பர் கெமிக்கல் அனாலிசிஸ் கண்டிப்பாக பண்ணணும். பட் lower grade of water is possible to be used. We have shown it with treated wastewater. Definitely can be used. But it will take time for that to get accepted.
We'll have QA session, a bit other session.
Yeah, I'll finish up this part and then we can continue.
We'll complete the second part.
Yeah.
And we'll have the other.
Good. I'm very happy with the kind of
much.
questions
Really,
that are being asked.
Interactive.
It's very good to see the kind of questions that are being asked. I'm very happy that you're thinking in these lines. This is what we want to do. Really, all these are questions related to sustainability.
Actually, Doctor, I would like to add up your few words. I think we are missing in the sense of, we are not emphasizing on durability requirements.
Exactly.
That is the reason where many of the projects, they're not going towards the sustainability.
Correct. Correct.
If we have, emphasize the requirements in the sense of durability, automatically everybody will be going towards the sustainability concrete.
Yeah. No, that's happening already. Durability requirements are coming into construction projects, but mostly with infrastructure projects. They are not there as much in the smaller building construction projects. But yes, we have a responsibility to make concrete durable even in those projects.
Because Doctor, since Chennai is a severe condition, still there are RCC structures going on with M25 and M20.
Yes.
So that is what I mean to say.
Correct.
We need to really understand the importance of the structure durability and its service life.
Correct.
Where we need to really think about the supplementary cementitious materials and its effects on the durability criteria. I have just seen only one project where they are asking for RCPT, whereas when we go for out of our India, there are many other durability requirements.
Correct.
Which we are still not at all started. So I think if once we take some initiative on durability criteria requirements, emphasizing on it.
Sure.
So obviously, I think in many of them will.
Yeah, definitely. This is something we are emphasizing everywhere.
Thank you, sir.
But definitely we'll do more of it. Yeah.
Thank you, sir.
Okay. So now coming to quality issues. Today, again, the topic was already raised: flowable concrete, special concrete, low temperature, mass concrete, and so on. These are special concretes or high performance concretes. High performance does not necessarily mean strength. It could be anything. Any performance that is not achievable in normal concreting is high performance. Okay, so it has measurable performance parameters. High strength means obviously strength is the parameter. High durability, chloride permeability, water permeability, all those are parameters you can actually measure. That's called high performance. But what about quality? Everybody has their own definition of quality, right? What you desire is what you get. But how do you measure it? How do you measure quality? Right? Tomorrow a construction project is done. What do you say is a good quality construction project? Some opinions. Sir, life you don't know, right? Tomorrow you're seeing the structure. How do you know how long it's going to last? By visual, how do you see what is good quality? Sorry? Appearance. So what is important about that appearance? About no cracks. Very important. No cracks. Second, finish of the concrete is what you desire. No damage, no honeycombing. Sorry? No visible porosity. Correct? Right? So all of these are qualities, but how do you measure them? Can you measure honeycombing? What level of honeycombing is bad? You can measure cracking, but do you measure cracking? You need cover, but do you measure cover? How do you make measurements? How do you produce, or how do you give a certificate to the building 12 degrees Celsius? So imagine if you place the concrete at 30 degrees, 12 into 4, 48 degrees increase in temperature can happen if it's a large concrete structure. If it's a tiny column or a beam, no problem, because whatever heat is generated because of cement hydration goes out, gets dissipated. But if it's a massive column, more than 1 meter in size, the heat inside does not go out at all. For instance, this is an example of a shear wall in a multi-storied building, which is 1.5 meters thick. The concrete inside, which is increasing temperature, that heat is not going out anywhere. It's trapped inside. So in this case, what they did was, at 24 hours, they removed the formwork on the surface and sprayed water. What happened? The surface cooled down to normal temperature, which would have been about 30, 35. But the core of the concrete was still having temperature of 75 degrees. Only later they saw that this concrete reaches its peak temperature of 75 degrees at 24 hours, maintains that for some time, and only then starts coming down. So what happened here? Temperature differential. The core was 75, the surface was 30 to 35 degrees at 24 hours when the concrete does not have sufficient strength. So, obviously, cracking happened. Concrete cracked all over the place. And this is because of the fact that they didn't pay attention to the temperature development of the concrete. What could have been done to reduce the cracking? What are the possible solutions? Sir, what I'm trying to say is, no, this is removal of formwork. What they did was they removed the formwork at 24 hours and sprayed water on the surface to cure it. So,
Slab and other structure we cannot remove.
This is not a slab, sir. This is a shear wall. It's a wall. So like a column, they removed at 24 hours and sprayed water. So what could have been done to prevent the cracking? While concreting, if they had brought the temperature down, instead of 30, if you make it 20, your core temperature goes to 68 instead of 78, right? And the difference in temperature is 68 to 35, slightly less, but maybe not enough to stop cracking.
Use of SEMs.
They could have used fly ash to reduce the temperature even more. But still, what else needs to
Design
be?
mix can be reduced. Instead of M40 they can go for M25.
Sir, no, sir. This is a shear wall in a multi-story building. This is M60 concrete.
Multi-story.
M60. Chill water to lower temperature. That's fine. But still, your core is still going to be at 68 degrees. So at 24 hours, if you take the formwork out and spray water, you still have a difference of more than 30 degrees with the surface. Sorry? No, you can wet. So that is while making concrete. That's all fine. But the problem here has happened after formwork was removed at 24 hours and water was poured. What should we do in this case?
Here ice concrete is recommended.
No, that's correct, sir. Lowering temperature was the beginning strategy. Yes, that is absolutely important. Whenever you do mass concreting, lower the temperature of placement. That is the first and most important thing to do.
Sir, instead of pouring water...
Sorry? Cure with hot water.
We can use
instead
GGBS.
of pouring water, we can use...
Curing compound could be used, okay. But don't cure with hot water, so it may not be a good idea.
Sir, instead of pouring water, we can use curing components and
You
cover
can use
the
curing
surfaces.
compound, but see again, come back to the original problem. I told you that the core temperature went up to 75 degrees at 24 hours, stayed there, and only then started coming down.
Sir,
We
core
can use
temperature maintain
GGBS.
பண்ணலாம்.
Sorry?
GGBS.
கோர் டெம்பரேச்சரை மெயின்டைன் பண்ற மாதிரி அவுட்ல ஏதா பண்ணணுமா? ஏன்னா அந்த டெம்பரேச்சர் என்ன இருக்கோ அதுக்கு ஏத்த மாதிரி வெளியில கொஞ்சம் சப்போர்ட் கொடுக்குற மாதிரி பண்ணணுமா?
என்ன பண்ணணும் சொன்னாங்க?
தெரியல, அதான் கேக்குறேன். அது மாதிரி இருந்தா ஒரு சொல்யூஷன் வருமா அப்படி?
இல்ல ப்ராப்ளம் எதனால வந்தது? 24 ஹவர்ஸ்ல நம்ம ஹோம்வொர்க் எடுத்துட்டு வாட்டர் ஸ்ப்ரே பண்ணிட்டோம். வாட்டர் ஸ்ப்ரே பண்ணலனா கூட ப்ராப்ளம் வந்திருக்கும். வாட்டர் ஸ்ப்ரே பண்ணதுனால ஃபாஸ்டா வந்துருது. வாட்டர் ஸ்ப்ரே பண்ணலனால
ரெண்டுத்துக்கும் டெம்பரேச்சர் டிஃபரன்ஸா இருக்கு. அவுட்டருக்கும் இன்னருக்கும் டிஃபரன்ஸா இருந்ததால தான் இந்த கிராக் வந்தது.
எக்ஸாக்ட்லி. அந்த டெம்பரேச்சர் டிஃபரன்ஸ் மினிமைஸ் பண்றதுக்கு என்ன பண்ணலாம்?
Pouring temperature concrete less பண்ணலாம் சார்.
எனக்கு என்னன்னா
pouring concrete temperature.
Sir, in the design mix you can add warm water, sir.
No.
Design mix you can add warm water.
No, sir. In design mix you add warm water, concrete temperature is already at 40.
Yeah.
So it will rise 48
Even
degrees over that.
You can reduce the Curing time also, if you add some warm water.
No,
in the design.
no, sir, no, sir. Please don't do this. It's a very wrong strategy. Whenever it comes to mass concrete, the answer lies in ensuring minimal difference between the core and the surface. How do you do that? You keep the formwork on. Use plywood formwork, which is insulating. Keep it on for longer time. Why do you want to remove it 24 hours and spray water?
Sir, provide vent holes also.
Which one?
Vent holes can be provided for the mass concrete.
Vent
holes.
Oh, that is inside.
Yeah, inside. See, outer to inside we can provide some holes.
Okay,
Vent
okay.
holes.
Deep holes.
Yeah.
But that's not going to sort this problem out, sir, because heat dissipation from core is not going to happen. This is a thermal shock problem. And this is happening because of the temperature difference. So in mass concrete, larger structures keep the formwork in place.
So then what about curing, sir? They said you have to start the curing within 24 hours.
Correct. So is this concrete going to suffer because you keep the formwork on? What is curing? What is curing?
Curing is the reaction
Providing
of
concrete a chance to hydrate without drying. Formwork is in place. Why should drying happen?
Excuse me, sir.
Formwork is there. You keep the formwork. For that, you need to understand. What do you need to understand? The temperature rise and fall profile of the concrete. For that, you need to have studied that at least a couple of months before doing the design mix.
Sir, how can we
Correct?
identify the cracks, sir?
Sorry?
Here, sir. How can we identify the cracks, sir?
So, as you said,
Wait.
If you are not-
I'm seeing multiple questions, but 1 minute,
Here,
one by
here,
one.
sir.
One by one, yeah.
so as you said, we can keep shuttering, but still in our cycle of construction, we will be planning one set of shuttering materials for first
Correct.
pour.
Correct.
The same will be used for the other pour.
Yeah.
So in the fast track project, we cannot keep the shuttering just like that. So instead, for your thing, what I suggest is remove the shuttering. That is required because the cost of shuttering will be more, so I cannot bring more shuttering materials. Instead, postpone the curing. Postponing the curing.
No, sir, but your surface is open, no? So it will still come down in temperature and still the thermal will be established.
There, but still when you are pouring the water, the external temperature will come down immediately. As you said, the core will be more. So there we are getting problems. Instead, remove the shuttering because we need to work on both the ways. I have to do the fast track project. Cost also, it's a point.
I understand, sir, but see, again, it's very important to understand this, that you do curing to ensure that no drying happens from the concrete.
Okay.
So in this case, if you're removing the shuttering and allowing it to air dry, you are totally going to be wasting the cover concrete and it's going to be poor in durability.
Okay.
So you have to cover the surface. Yes, you may adopt a strategy to remove formwork, but you still need to cover the surface, let's say with some thermal insulation like a styrofoam block or a thermocol. You can put thermocol. But all that, again, requires a lot more planning. Special concrete like mass concrete, you have to ensure that you are studying this well ahead in advance, understand this temperature rise and fall. Today, increasingly, I am seeing a lot of problems are being caused just because of this thermal cracking. Tons and tons of problem of thermal cracking. Okay? So it's very important. So what I want to drive home is that, yes, place concrete at low temperature, but please study the temperature rise and fall of the concrete so that you decide your curing operations appropriately. Okay? Ultimately, you have to do long-term curing, no doubt about that. Curing cannot be lived without. But as long as the surface is protected by the formwork, you are safe. You can delay the time that the formwork is removed. Yes, productivity is important. You need to look at the project also, but you need to make the decision. Do you want to risk cracking at the cost of reusing the formwork, or do you want to make sure that the concrete produced is of high quality? So make that choice and ensure that you stick to it. So what point I want to drive home is, in thermal cracking, avoiding thermal cracking, you need to ensure that you understand temperature profile of the concrete. There are easy ways to study this. It's not difficult at all. Take an ice box, thermocol box, right, where people used to sell ice creams in. Take that box, fill it up with concrete, close it, seal it, keep monitoring the temperature using thermometer or thermocouple. Very, very cheap. You can make this entire setup in less than 2,000 rupees. You can measure these things. It's not difficult at all. Why are we shying away from doing more and more testing on the concrete? It's easy testing. All this can help you in the long run, okay? So, the other problem is retempering and redosing. We see this all the time, okay? There was a site at which I was called, the concrete had not set for 3 days. Concrete had not set for 3 days. In fact, after 1 day, the foreman at the site used an iron bar to actually touch the top surface, thought that it was dry, right? It was dry to touch. So, opened the formwork, concrete collapsed. The concrete had not set, concrete had not hardened, okay? So I went to the site 3 days after construction, after the concreting. So I first went to the site and I actually saw the concrete. I could still smell the chemical admixture in the concrete, okay? Then I went to the QC lab. I told them, okay, now bring me the cubes that you made with the concrete. They brought me the cubes, looking fantastic. We tested the cubes. The 3-day strength was exactly what we need from it. But the concrete and the structure is not set. What happens? The truck that comes from your ready-mix concrete plant first comes to the QC lab, where you prepare your concrete and you put the concrete in ideal conditions, nice storage and all that, and then you test it. The same truck goes to the job site. Maybe the site is not ready to receive the concrete. Some formwork and reinforcement tying is still going on. The truck stands for 2-3 hours at the site. The workability goes down. Sorry? Yeah, they may have poured late, because of which the workability came down. So they added water. Or today, because people are increasingly vigilant about adding water, they may have added extra super plasticizer. So when you add too much super plasticizer, it's like overdosing. Overdosing produces retardation. Concrete does not set. Sometimes I've seen sites where concrete is not set for 7 days. Okay. At the site, they added extra super plasticizer. Concrete did not set, and that's why it collapsed when the formwork was opened. But in the lab, they didn't add the extra admixture. Concrete was quite good. It produced the right strength. So retempering or redosing, you need to be very careful about. So ultimately, whatever you do, you are at the mercy of the frontline operator. You need to train them. You need to ensure that they understand what it is to actually make the concrete well. Plastic shrinkage. Okay, if you go to a common house builder, they'll tell you that they don't want RMC. They want only in situ concrete because RMC cracks. Why should RMC crack? It's also concrete, right? The difference between in situ concrete and RMC is that RMC is produced with some level of quality control with optimized level of ingredients, water, cement, admixtures, and so on and so forth. Most of RMC also tries its best to utilize fly ash. Okay? In situ concrete, we mix the concrete in the mixer, we pour it. Usually it has excess water. When you make concrete with excess water, let's say for the slab, very high surface area, we make concrete with the excess water, what happens to the water? It bleeds. It comes to the surface, it forms a nice film. Any evaporation that happens only removes that water. Okay. But what we don't realize is that bleeding reduces the quality of my cover concrete tremendously. Bleeding is bad for concrete. But bleeding is good from the perspective of not cracking the top surface, because the water is drying away, concrete is not dry. Whereas in RMC or in concrete that has a lot of these mineral additives like fly ash or slag, the concrete is optimally designed so that it can be transported to the site, maintain its slump, and then poured and finished. In such cases, setting is slower, okay, because of fly ash and other ingredients. And if the foreman is not on site, the workers are not on site observing the concrete, especially slabs, we are not worried about beams and columns, primary slabs which I am talking about. In such cases, if there's wind, if there's sunshine, in such instances, drying of the concrete actually happens because there's no bleeding, so the concrete starts drying. Once concrete starts drying, it's producing plastic shrinkage cracking. That's why we call it plastic shrinkage, because it happens when the concrete is still in a moldable state or plastic state as we call it. How do you avoid plastic shrinkage cracking? you need to start early curing. For starting early curing, you need people on site. You can't say that I've finished my concrete and tomorrow I'll come back and start curing. No longer can you do that. You need to ensure workmen are on site, especially large slabs like this. You need people on site. There are different ways in which you can restrict cracking. One, cover the surface. Take a plastic sheet, cover the surface. What does that do? It prevents evaporation. You can simply cover the surface. In many cases, that works. If cracks start to appear during the process of concrete, because such a large slab, it will take long time to pour, no? Cracks may start to appear at some sides. Take a wooden float. In Tamil, we call it maniyaskatte, right? Take the wooden float and simply rub the crack, it will go away. Because it's only forming at the surface. So wherever it forms, you're rubbing it and making it go away. Simple enough. Very simple solution, but what is important is you need people on site to do that. You need to have your workmen available on site. We did a recent structure in IITM where very large terrace, open terrace, we poured in a single shift of concreting. A lot of cracking happened. But then there were people, we had prepared for this. We had people, we told the contractor to ensure that people are there on site who can do this. And finally, the structure was produced without any cracking. Simple enough. Okay? Early curing, covering with a sheet, or just using a wooden float when the cracks start appearing. So you have to be very vigilant while casting large slabs. And especially this is a problem when you start using flowable concrete, like self-compacting concrete. A lot of problems can actually happen like this. Segregation. Flowable concrete can often get segregated because of many reasons. One is you have not designed the mix properly. There is not enough fines in the mix. Second is you have over-vibrated the concrete. Too much vibration is also bad for the concrete. Okay? Third could be redosing, too much chemical admixture. At the site, people have added additional chemical admixture without understanding its significance, because of which it starts segregating. Very important to not do this. Another common site in many projects today is the use of fusion bonded epoxy coated bars. Right? Why are we using this? To ensure that steel will not corrode. Yeah? So the coating of epoxy is bonded on at high temperature on the steel surface, and that prevents the steel from corrosion, or so we think. The problem on site is very different. We handle our bars like this. We do bar bending, right? All our processes on site ensure that this coating does not remain in place in many locations. You can see how it's gone. In several locations, the coating is gone. And already rusting has started. And when you put this in concrete, it's going to create more problems than it is solving. You are already creating sites where corrosion can start. When you put a regular steel in concrete, you have to wait for some time for that to happen. Here, you don't have to wait. It starts immediately. Okay? So, be very careful. Confidence in coated bars only comes when the coating is perfectly maintained. On site, bar bending and handling on the site can often give rise to such problems. In some cases, I've seen in sites that they even use a green paint wherever such things have happened. That paint is not going to do anything for you. It is not a fusion bonded epoxy coat on the steel. So, important to control cracking. Less cement is good for cracking, right? Less cement means less potential for cracking. Early curing, avoiding high temperature differentials. Shrinkage cracking needs to be controlled significantly. And when you're making slabs, you also cut joints on the slab, right? Cutting joints on the slab, it has to be done at the right time. If you do it too early, the joints will close. If you do it too late, concrete will get damaged badly. So you have to cutting at the right time. Maintaining cover is the key to durability. Okay, so you need cover blocks, obviously, which are properly designed and tested, so that when you do the vibration of the concrete, the cover blocks don't get moved on their own. They have to retain their position. But what happens in many sites is that the cover blocks basically get dislodged. Okay, and some sites don't even use proper cover blocks. As a result, they get problems like that, right? So what you need to do is, what you need to do is ensure that it's not just the quality of the concrete, but also the quantity of cover that you have that is important. So you can actually use a cover meter to measure cover. After the construction is done, let's say in your specification, if you have a spec of putting 1% of your structures need to be tested for the cover, that work on the policy initiatives that will make this possible. So this is a group that we have, and together we are working on these technologies for low carbon and lean construction. Any of you who have specific ideas that you want to explore and want to talk about in this area, mainly to produce sustainable concrete in the long run, are welcome to please come and interact. Should I think about it? No. Nobody allows it. You need to convince them to allow it. You need to make sure it's operational. And epoxy coated steel, there is no film that is forming. It's just the layer on top, the plastic, that is preventing steel from corroding. So if the plastic is damaged, steel will start corroding.
Good evening, sir.
Good evening.
Concrete reducing பற்றி சொன்னீங்க. இப்போ ப்ராக்டிக்கலாக வேறு சைட்டில் அதுக்கு ரீடூசிங் இல்லாமல் அவாய்ட் பண்ணுறதுக்கு வேறு எதுவும் சொல்யூஷன்ஸ் இருக்குது?
அதுக்கு தான் நம்ம வந்து பிளான்ட்டில் வந்து ஹையர் ஸ்லம்ப் சூஸ் பண்ணோம். அப்போ வந்து சைட் ரீசார்ஜ் ஸ்லம்ப் will slightly reduce இல்லையா? The reduced slump should be capable of still passing your job site specification. இப்போ ஒருத்தர் சொன்னார் இல்லையா முன்னாடி, I mean, about 2 to 3 hours of its arrival at the job site. மும்பையில் வந்து எல்லா கான்கிரீட்டையும் வந்து 3 hours.
How to use the simply
This was a positive thing, right? Because CO2 gets absorbed, lime transforms to calcium carbonate and hardens the structure. In concrete, again, from strength perspective, it's a good thing. But the problem is, because you're converting lime to calcium carbonate, your pH of the concrete is going down. Or as document, right? It'll come. The concepts of durability design, what I just talked about, choosing a cover more than the penetration depth of CO2 for a given mix design, yes, it will come, because of which we may start using more and more of these supplementary materials. But as of now, IS 456 already talks about using all these materials.
Yes. My question is that there is a minimum cement content that is prescribed, but will there be a percentage of fly ash and GGPS that can be used for a particular grade of concrete?
Actually, if you look at the minimum cement content criteria also which are given, right, it clearly specifies that cement is inclusive of additions.
Thermal concreting and the using of ice flanks and monitoring of moisture corrections. So such a things we are experimented and we are done the results. So that things from your end we are feel good, sir. So we are explained and we are that the thing I want to register, sir.
Okay, 24 degrees. Yeah.
We have done the concrete with the 24-degree placing concrete temperature, sir. So the same thermal monitoring we have done. So that peak
temperature are because the air is not finding a way to come out.
Yes.
So in some cases, some holes on the formwork, weep holes on the formwork can help in taking away some of this excess air. Another possibility is you probably need to look at the formwork oil that you're using or form release agent that you're using. Okay. And in some cases, use of a different form release agent can also help in reducing the extent of bug holes that form. But yes, this is a quality problem. As I said, it's very difficult to measure.
Fine. So, thank you, sir.
Doctor, hot water or steam water curing பண்ணலாமா?
Hot water or steam liya?
Steam.
Steam la கண்டிப்பா curing பண்ணலாம்.
அது எவ்வளவு நாள் கழிச்சு பண்ணணும்? இப்போ நம்ம அந்த ஹீட் ஹைட்ரேஷன்
இல்ல இது வந்து ஒரு கண்ட்ரோல் கண்டிஷன்ல பண்ணணும். ஸ்டீம் கியூரிங் வந்து நம்ம கான்கிரீட் பிளேஸ் பண்ணிட்டு இனிஷியல் செட்டிங் இருக்கு இல்லையா, அந்த டைம்ல ஸ்டீம் டெம்பரேச்சர் இன்க்ரீஸ் பண்ணணும் ஸ்லோலி ஃப்ரம் ambient conditions to the high temperature. High temperature in steaming should be ideally around 60 to 70, not more than that. So அந்த டெம்பரேச்சர்ல வந்து ஸ்லோஸ் இண்டஸ்ட்ரியில் ஸ்டீம் கியூரிங் வந்து நம்ம ஆக்சலரேட் பண்ணுறது தான் லைஃப் சைக்கிள், ஐ மீன் ஸ்ட்ரென்த் கெயின் ஆக்சலரேட் பண்ணுறது தான் நம்ம பண்ணுறோம். ஸோ அதில் வந்து யூஸ்வலாக 7 days நார்மல் கியூரிங் ஸ்ட்ரென்த் வந்து ஒரே நாளில் உங்களுக்கு வந்தது ஸ்டீம் கியூரிங்கில் வந்தது. பட் அகெயின் தட் டிபெண்ட்ஸ் ஆன் யுவர் கான்க்ரீட் மிக்ஸ் டிசைன். இப்போ அதே டிசைனில் வந்து நான் வேறு மாதிரி கூட டிசைன் பண்ணலாம். I can go for 40% of the strength at one day because I need to lift the module, or I can go for 70% of the strength at one day because I need to achieve the potential grade at one day itself. Depends on the application, depends on the requirement. அந்த மாதிரி நம்ம மிக்ஸ் டிசைன் பண்ணி அந்த ஸ்டீம் கியூரிங் ஸ்ட்ராட்டஜி டிசைன் பண்ணணும்.
நம்ம இப்போ சாதாரண சைட்டில் காலத்துக்கோ அல்லது ஸ்லாபுக்கோ நம்ம ஸ்டீம் கியூரிங் பண்ணலாமா? ஸோ நம்ம நிறைய எக்யூப்மெண்ட் அது மாதிரி இருக்குது.
சைட்டில் வந்து ஸ்டீம் கியூரிங் பண்ணுறது கொஞ்சம் கஷ்டம். ஏன்னா யூ நீட் ஸ்டீம் ஜென்ரேட்டர்.
அது மாதிரி ஒரு எக்யூப்மெண்ட் இப்போ நிறைய வருது, வேற வேறு பர்பஸ்க்காக வருது. அதை ஒரு ட்ரையலாக எடுத்து பண்ணலாமா?
ட்ரையலாக யூஸ் பண்ணலாம் கண்டிப்பாக. நீங்கள் வந்து ஒரு ஸ்லாப் கிராஸ் பண்ணி பாருங்க. ஒரு ஸ்லாப் போர்.
We would like to show our gratitude for our chief guest by honoring him with a memento. I would like to call upon Mr. Tagore to come on stage and do the honors of giving away the memento. So much for your patience. We will be running around a couple of more minutes alone. Now I'd like to call upon Mr. Barney Rajan, Business Manager, Concrete OEM Private Limited, who would like to share a few words, and he would like to be doing a release of a stamp. Mr. Barney Rajan.
ரொம்ப தேங்க்ஸ். இவ்வளோ நேரம் எங்களோட இன்விடேஷன் எடுத்து இங்கே வந்து எல்லாம் இருந்து ஒரு யூஸ்ஃபுல்லாக யூட்டிலைஸ் பண்ணதுக்கு ரொம்ப தேங்க்ஸ். ஒரு சின்ன ஒரு 5th இயர் ஆனிவர்சரியில் இருக்கோம் நாங்கள். அதனால் அதை செலிப்ரேட் பண்ணுற விதமாக ஒரு இந்தியன் போஸ்டல் ஸ்டாம்ப் ஒன்று வெளியில் நீங்கள் பார்த்துருப்பீங்க, செல்ஃபி போர்ட் பக்கத்தில் இருந்திருக்கும். அதை டாக்டர் மனு சந்தானம் மூலமாக ரிலீஸ் பண்ணி அதை எங்கள் எம்டி மிஸ்டர் தாகூருக்கு கொடுக்கலான்னு நினைக்கிறேன். அதனால் கொஞ்சம் 2 பேரும் மேடைக்கு வர மாதிரி அன்புடன் ப்ளீஸ். இது நேற்று நம்ம சென்னையில் இருக்கிறதுனால இந்த மேண்டோஸ் புயலை பற்றி கேள்விப்பட்டிருப்போம். மேண்டோஸ் நேற்று கிராஸ் ஆகிடுச்சு. ஆனால் இப்போ இந்த மேன் இன்றைக்கி வரைக்கும் டஸ் கன்டினியூ பண்ணுவார். அதே மாதிரி இப்போது ஒரு சின்ன சிஸ்டம் அடாப்ட் பண்ணிகிட்ருக்கோம். யூஏஇன்னு பேர். அண்டர்ஸ்டாண்ட் பண்ணுறோம் உங்களோட ரெக்யர்மெண்ட்டை அடாப்ட் பண்ணிட்டு அதை எக்ஸிக்யூட் பண்ணி தரோம். அதை கண்டினியூஸாக பண்ணுவோம். இன்னும் உங்களை மாதிரி நிறையா சப்போர்ட்டர்ஸை இதில் கொண்டு வருவோம்.
Big applause, please.
Please give a round of applause. Coming to an end, I would like to call upon Mr. Jagannatha Rao to provide the vote of thanks.
It's an honor to me to have been asked to offer the vote of thanks on the occasion of technical meet here. We have been fortunate to have two renowned, I need to correct it, and I need to